All right, today's assignment, we worked again on graphing quadratics, and this is a little project that I had students work on in class. This is the worksheet, and when we talked about this, we actually created a table of values, and I had everyone graph the equation y equals x squared, or make a table of values, I should say, for the equation y equals x squared. And I'm going to remind you of how that works. So we make a t-chart. We have a column for x and a column for y. And when we're trying to find points that would be on the graph of y equals x squared, typically what I'm going to do is I'm going to pick some negative values of x. I'm going to put in 0, and I'm going to put in some positive values of x. Now, what I have is the equation y equals x squared, which is x times x, right? So here, for this particular x value, when x is -3, I get -3 times -3, which is positive 9. Negative times negative turns into a positive. Here, I'm going to get -2 squared, or -2 times -2, which is positive 4. When x is -1, I'm going to have -1 to the second power, or -1 times -1. Remember, that's x times x. So I'm doing -1 times -1, which is positive 1. Notice all of these output values, all these y values are going to be positive until we get to 0, because 0 times 0 is still 0. And that's going to give me a low point because all of my other points are going to be above that. They're going to have y values that are bigger. So here I have 1 squared, which is just 1. Here I have 2 squared, which is 4. And here I have 3 squared. Remember, 3 times 3, which is 9. Okay? So notice this is the graph that we get. So this is the graph of y equals x squared over here. Here's the point -3, 9. Then we have the point -2, 4 down here. Then we have the point -1, 1, and so on. The origin, which is our 0, 0. Notice that's the lowest it will go because all of my other y values are bigger than 0. And we take a number and we multiply it with itself. If it's a real number, negative times negative turns into a positive, and a positive times a positive is a positive. So our graph has a low point at 0, 0. So the vertex is 0, 0, right? Vertex is 0, 0. And I want to look at this as being in vertex form because we're going to explore vertex form. So I'm going to look at it a little weirdly. I'm going to take this vertex form, which is down here. There's our vertex form. And I'm going to figure out what all the pieces are. Well, the A is 1. The H is 0. This is my H and K, right? And my K is also 0. So there's my y equals A times x minus h squared plus k. So as we go through this task, this project, I want you to do some exploring in Desmos. And I'm going to show you how to get to Desmos in just a minute. So we're going to do some exploring in Desmos. And I'm going to ask you to change the value of A. I want you to look at what happens when it's positive numbers. So maybe we could play with values like A equals, we already have a 1. What happens if I change it to a 2 or a 3 or a 5.5? And what happens if I change it to something smaller than 1, like a 0.2 or something like that? But positive numbers, okay? And then if A is 0, this gets really boring because my f of x is not going to involve an x squared term, so it's going to be a line. So this one is not even a parabola. And we're really only studying parabolas. So if it's actually going to be a parabola, a quadratic function, a can't be 0. Right? So if a is 0, we really want to work with that case. Now, remember that when a is negative, the parabola is going to open down. But I want to think about what happens if we have things like -2 or -3 or -5.5 or -0.2. And if you need more, do some more. What if a were negative 1/5. Oh, that's negative 0.2, right? What happens when we get close to 0, like maybe a negative 0.01, for instance? We're going to look at some of those things, okay? So we're going to explore a little bit. Now, as you start your exploration, I'm going to ask you, as you're exploring what happens with the A, I want you, at least for now, to leave the H as 0, leave the K as 0. And then once you've done some exploring and see what A does, and you've figured out what the H and the K do, then put it all together. So at first, when we're exploring what happens with H, I want you to leave the A as 1 and the K as 0 and just change the H. So maybe you look and see what happens when H is 1 or 4, just positive numbers now, or 0.25. How does the graph change when we make changes to the A value, or the H value, sorry, the H, we're working with H. What happens when H is 0? What happens when H is a negative number? So like maybe negative 1 or negative 4 or negative 0.25. How does that affect the graph of my quadratic? All right, down here, leave the A equal to 1 and the H equal to 0 and only change the K. And you can pick some K values. So you need some positives, you need 0, you need some negatives, and see what happens. So I'm going to grab go out to Desmos, and I'm going to type in desmos.com, and I'm going to pull up the graphing calculator. So I'm going to click right here on the graphing calculator. So you can go that way, or you can type in the address I gave you on the notes, either way. So I'm going to pull up the graphing calculator, and I'm going to type in y equals x to the second power. Now I can either do a shift and a 6, or I can pull up my keypad here to get my square. So there's the quadratic y equals x squared, the one that we have on our paper. Same graph, okay? Now we're going to look at what happens if we change the a value a little bit. So what if I had y equals, what a value did I work with first? Let me go back and take a look. 2, 3, 5.5. Okay, and then 0.2. So y equals 2, y equals 2x to the second power. Notice what happens. The vertex is still in the same spot, but the new parabola is steeper because we've multiplied all the old y values by 2. So we've made them all twice as big, so it's going to be steeper. Let's look and see what happens if we do y equals 3x to the second power. Oh, it's even steeper. Okay, so as a gets bigger, if a is positive and it gets bigger, my parabola gets steeper. So we'll put that in our table here in a little bit. 5.5x to the second power should be even steeper. Yes, it is. Okay, what happens if we do y equals 0.2x squared? Oh, look, less steep. So if I compare with, let's click these guys off for a minute. Let's compare with our parent function. So there's our parent function, y equals x squared. That's our basic parent function, y equals x squared. And y equals 0.2x squared then is in the black. Notice it's wider. It's not as steep. So the closer you are to 0, the wider the parabola. So we're going to go back and we're going to put something on our notes here. And we're going to say that when a is, so you could say it in different ways, but so if a is close to 0, or you could say as a gets bigger, the parabola gets steeper. So as a increases, or as a gets bigger, put it in your own words, something that's going to make sense to you. As A gets larger, bigger, the parabola gets steeper. Vertex doesn't move. It just controls how steep the parabola is. Okay? And then we could do the same thing with negatives. So let's take all these guys that we have and let's just change them to negatives. So what if we had -1? Right? What if we had -2? What if we had, oh look, our parent function y equals -x squared in red. The blue one is also upside down because we have a negative value of a, but it's steeper, right? Green one, even steeper. This one's going to be even steeper. And last but not least, if I put a negative in front of that one, flips it upside down, least steepness of all of those parabolas that we've graphed, right? So the A controls how steep it is, as well as whether it opens up or down. Interesting, huh? Okay, I'm going to get rid of all those, and we'll play with a little bit with, I'll show you what I'm talking about with some of these others. Okay, so here we go. So you can fill in what happens over here. Fill in your explanation of what's going on here. So now let me go back to the H, and we'll play with H a little bit. So I have a 1, and I have a 4, and a 0.25 that I'm going to do for my positive values of H. Then I'm going to do the negatives of those. So like we said, at first, we're going to do y. I'm going to compare it to y equals x squared. I shouldn't have gotten rid of that one. So we're going to compare it to our parent function. And let's do y equals, we'll leave the a as 1, but we're going to change this to x minus 1, x minus h. Notice where it went. It went 1 unit to the right. The vertex is now at 1, 0, right? 1, 0. Okay. And let's do the next one. We'll do y equals x minus 4 squared. Notice where that one went. It went 4 units to the right. So we took the parent, y equals x squared, and it went 4 to the right. Over here, vertex at 4, 0. And we'll do one more. We'll do y equals x minus 0.25 squared. Oh, it moved a little bit to the right, but only by 1/4. So when h is positive, it's going to shift that parabola to the right. Okay? If h is negative, I want you guys to think about what happens if h is negative. If h is negative, oops, I don't need to wear the forecast. If h is negative, then my equation is going to be y equals something like that. Let's just plug in we'll leave the a as 1. Minus a -4 becomes a +4.
It's the Great David Grizzlies.
And we'll have k equals 0.
We will now be announcing the top 24 for boys and girls for prom royalty in no specific order.
All right, so for your boys, we have
I'm going to
Drew
go back and
Marler,
graph.
Jason Liu, Lucas Abbott, Braden Smith, Ryan Mounts, Mason Pettit, Joseph Hackinson, Devin Avalos, Chance Brooks, Santos Marquis, Brennan Bueller, and Tyson Hyman.
And for your girls, you've got Maya Hendricks, Kennedy Johnson, Emily Loffelby, Emily Wolfgram, Kylie Kessler, Araya Gilbert, Anna Yu, Bree Gordon, Ashlyn Hanna, Alyssa Thompson, Purdue Sadabatula, and Ari McBride.
Congratulations for those of you that made it this far. Next voting for top 12 will begin tomorrow during A and B lunch, as well as for Thursday. Voting will be for juniors only.
Okay, so notice.
Right, guys, and also remember to come out to the girls' basketball game today. It's at home versus Rangers. Team is Navy.
So notice I've now graphed them with the positive, with the plus sign in between, where h is negative. because the x plus 4 squared is the same as x minus negative 4, which means h is negative 4. So notice where our vertex is for the one in the middle, the green one. Looking at the green one. Negative 4 comma 0. Okay? Notice the blue one. The vertex is at negative 1 comma 0. So that plus 1 moves it to the left. The purple one barely moved to the left, but it's only a quarter. That's why it looks so close. So we only moved it 1/4 of a unit to the right. Okay, and I'm going to let you play with the k values. I'm going to end this video here. Play with these values a little bit and look at what happens when you change everything. And can you make predictions? Make some predictions. So if I had y equals negative 2 times x plus 3 squared. So it's going to open down because a is negative. It's going to move to the left because h is negative. And if I do a plus 4, my vertex is negative 3, 4. So notice where the h moves us to the left. Where does the k move us? Up. And the a changes how steep the parabola is. And if a is negative, it flips it upside down.